In this video, we're going to look at just a few circuits that are a bit more complicated. Specifically, we're going to look at some situations where we have what's called a short in a circuit. And also, we're going to look at what happens when you connect multiple branches up to a particular voltage supply. So, in this particular case, I have a circuit that has two light bulbs that are connected one to the next one. So it seems as though if I could just look at these two bulbs, B and C, they seem to be connected in series. And then I have another bulb, A, which is connected to those two bulbs, B and C. And it almost looks like a parallel connection if you were to combine these two bulbs together. So let's just think about what's going on here. So the question is there a significant change in brightness of the single bulb A when the branch is connected, bulbs B and C, and what does this imply about the current that passes through bulb A before the branch is connected as compared to after? So what we're going to do is we're going to use the PhET simulation. I built this circuit. And what we're going to do is we're going to have just bulb A connected in the circuit, and then we're going to connect this other branch. So B and C together form a branch that is connected to that voltage supply, and then A is also connected to that voltage supply. So let's go ahead and take a look at that. So this picture is slightly different than the picture in the PowerPoint presentation. I actually have, here's my bulb A, here's bulb B, and here's C, and then I actually have some additional bulbs, but this switch is open and I'm not going to close it. So the first thing I'm going to do is I'm going to go ahead and I'm going to close the switch here, and so this light bulb is connected independently to that voltage supply, and this is considered a branch of that circuit, and I can see how bright it is. Not only can I see how bright it is, but if I wanted to, I could actually check the current that's going through there, and there is 3 amps of current going through that. This is a 10 ohm bulb, and I set the voltage to 30 volts. So that makes sense. 30 volts over 10 ohms is 3 amps. So the question is, if I close this part of the switch and I add this additional branch, what's going to happen to the brightness of this bulb? And of course the brightness is associated with the current. So if the current through this bulb stays the same, then the brightness is also the same. So let's go ahead and close it. And what I notice is that by closing this switch here, the current that passed through that bulb A stayed the same and the brightness stayed the same. So I'm going to disconnect it and the brightness stayed the same, and then I'm going to reconnect it, right? So that brightness stayed exactly the same. I noticed that the bulbs B and C seem to have the same brightness as one another. They're both 10 ohms, but they are not as bright as bulb A over here. And the reason for that is because these two bulbs are sharing that voltage supply. So this is what we're going to do. We're just going to disconnect this switch, and if I look at my circuit now, I basically have one voltage supply. I have current that comes out, passes through the first bulb B, passes through the second bulb C, and then goes back to the battery. So right now these two bulbs are connected in series. They're sharing that voltage supply, so they are not going to be as bright as a single bulb that's connected to that battery. If I disconnect these and then I connect this bulb, I have one bulb connected to the voltage supply, and it's getting all of that voltage passing through it. Oops. So let's go ahead and close both of them again. The current that passes through both of these bulbs is only half of what it was for the single bulb. It's 1.5 amps because those two bulbs are sharing that voltage. There's more resistance in this particular branch. So 3 and 1.5, and then of course the current that goes through the battery when both of these branches are connected is 4.5 amps. So when you have these branches that are connected to a battery, they are actually independent of one another. So if you change something in one branch, it doesn't affect the other branches. If I go ahead and I disconnect here, right now all of the current is coming from the fact that the battery is connected to just bulb A. It's 3 amps, and if I were to open this one, all of the current is coming from the two bulbs being connected to the battery, which is 1.5, and then of course together it's the total of both of those together. So that sort of shows us that these branches are independent of one another. So the current doesn't change through each section, independent. So when one branch is connected or both branches, the branches independently have the same current passing through them as they would when the other branch wasn't there. And that's because of the fact that they are each independently connected to the voltage supply. How does the brightness of bulbs B and C compare to the brightness of bulb A, and what does this imply about the current? So we already answered that question, right, when we looked at this. These are not as bright, the current is less. This is brighter, the current is more. All right, let's look at the next one. All right, so now, does the current that passes through the battery change after the parallel branch is connected to bulb A? If so, how does it change? What happens to the brightness of bulb A and bulb C when bulb B is unscrewed? And so let's look at that. So we sort of already answered that question as well. So the question is, let's go back to our picture. So what happens to the current that comes out of the battery as we add these branches, right? So I put the first branch in with a single bulb and I get 3 amps because there's 3 amps connected here. And then when I connect the next branch, the current through the battery goes up to 4.5 because I have 3 in one branch and 1.5 in the other, more resistance in this particular section. The other question is, what happens to the brightness of the bulbs when I disconnect bulb B? So this is bulb B, and the only way to really disconnect it, you can't unscrew the bulbs in the circuit, but you can use the scissors and disconnect. So what I notice is that when I disconnect or unscrew bulb B, because B and C are essentially in series with one another, bulb C also goes out because there's no longer a complete circuit for current to flow through bulb C. But bulb A over here still stayed exactly the same brightness because, again, it's independently connected to the voltage supply. So parallel branches are independent of one another. A change in one branch is not going to significantly affect the other branches. Of course, this is a perfect circuit too, right? So there's no resistance in the wires and so on. All right, so now we're going to put a third branch in. So what would happen to the brightness of bulb E over here if A is unscrewed? Is bulb E going to become brighter, dimmer, stay the same? And what would happen to the brightness of B and D if E is unscrewed? B and D, excuse me. So basically, let's just see what happens when I unscrew different bulbs here. So the first thing that I need to do in my simulation is go ahead and close all my switches. So I'm going to reconnect, and then I'm going to connect here. So in the last circuit here, so I have A, B, C, D, E, and F in terms of my bulbs. I notice that bulb A is the brightest because there's only one circuit, and that voltage, all of the voltage of the battery goes to that one bulb. When I have 2 bulbs, the voltage has to split between those 2 bulbs that are essentially in series. And then when I have 3 bulbs, that voltage has to split between the 3 bulbs. So the current is maximum and the brightest bulb in A. It's less bright in B and C with 1.5 amps. And then when I get over here, the current through all of these bulbs is only 1 amp, so the bulbs are not as bright here. So what happens to the brightness of the bulbs if I disconnect A? So let's go ahead and disconnect A. Well, when I disconnect A, the brightness of the bulb stayed the same because this branch is independently connected to that voltage supply. I have a way of starting at the battery, going all the way up, and making a complete circuit through those bulbs and back again. So those 3 light bulbs are sharing that voltage, and these 2 light bulbs are sharing that voltage. Now the current here has stayed the same. The current through the middle section has stayed the same. The current through the battery, of course, has decreased. So if I reconnect this, right, then the current goes up again because this battery has to supply current to that bulb. So disconnecting this bulb A, all the rest of the bulbs stay exactly the same brightness. All right, so we reconnect bulb A, and now let's disconnect bulb, oh, I forget, disconnect E. So disconnect this one and see what happens to B and D. So let's do that. So we're going to disconnect bulb E right here, and let's see what happens to the rest of the bulbs. So when I disconnect bulb E, bulbs D, B, C, D, E, and F, right? All of those bulbs go out because there's no longer a complete circuit there, and they were connected essentially in series with one another and then to the battery, but the brightness of the other bulbs stayed the same, right? So bulb A still has 3 amps and it's still as bright, and the other 2 bulbs have 1.5 amps and they're still just as bright. So branches there are independent of one another. All right. Now let's look at something that's a little bit more complicated. So here I have a light bulb that is connected to another light bulb, but then there's also a switch in this circuit. And so we want to know how the brightness of bulbs A and B compare when the switch is opened, and then what happens to the brightness of B when the switch is closed. When the switch is closed, bulb B essentially has a wire connected across it. What does this behavior of bulb B when the switch is closed imply about the way current divides? So let's take a look at that. So here we go. We have another picture. Here's our picture right here. My switch is opened. I have my battery set at 30 volts, and each of my light bulbs are 10 ohms. So right now, they are both about the same brightness as one another. And I notice that the way that they are currently connected is that the current, electron current, goes through one bulb, gets to this other junction, passes through the other bulb, and comes back around. And because the switch is opened right here, current cannot flow through this other section. So these 2 bulbs right now are essentially connected in series by this to this voltage supply right here. So the question is, what happens if I close the switch? So let's see what happens when I close the switch. So when I close the switch, bulb A gets much, much brighter, and bulb B goes out. And the reason for that is because this is a little bit more complicated circuit. So think about what's happening here. The current is leaving the battery. It gets to this junction right here, and it has a choice. Some of the current could go up through the light bulb B, and some of it could go through this path over here, and then they meet back up, and then they're going to go back, they're going to go through bulb A and then back around. So this is a very special example. This is called a short circuit. The switch, when it's closed, this part of the wire has 0 resistance. So when the current gets to this junction and it has a choice to follow the path over here, which has 0 resistance, or to follow this path here where there is resistance, kind of like you're on a road, right? You get to this point right here and you can choose to go the route that doesn't have any tolls and you just keep on flowing with traffic, or you can go and you have to stop at the toll and so on, right? So the current is going to follow the path of least resistance, and since there's no resistance here, that light bulb gets 0 current. All of the current passes through the short and then it comes back around. So this is a situation where the light bulb A is now behaving as if it's connected just to the battery with nothing else connected. So if I open this back up again, right, current can't flow through that short and the current can go back around. Okay, so let's look back at this example. I think we've answered those questions. So what happens to the brightness of B when the switch is closed? Bulb B goes out and bulb A gets brighter because of that short. So when B is shorted out, what happens to the brightness of A? So the brightness of A gets brighter. How does the current through the battery change, and how does the total resistance change? So that's one thing we didn't answer. So here, let's pull out the ammeter to measure current. Here's the current when the switch is opened and I have both bulbs connected. When I close the switch, let's see what happens to the current. the current increases because now I only have one bulb in the circuit. Before it was two bulbs basically connected in series, and so now the current is greater. And so when I close that switch, there's less overall resistance in the circuit because the current has gone up, and as the current goes up, the overall resistance goes down. So before we go and close out of this, I wanted to show one more quick example here. I'm going to open this switch and I'm going to take this bulb out just for now. Ooh, uh-oh. I did not mean to do that. All right, so we'll use this one. It's fine. So I'm going to take out this bulb, take this out, and I'm going to do this. Okay. So I took the light bulbs out of this middle section here, and the rest of this I don't care about for now, right? So here's another example of something where you have a short in the circuit. So I have my battery, and it's connected to just this single light bulb, right? Coming around, of course, it's getting the 3 amps. And then I have another section where there is nothing. There are no bulbs connected here, and there's a switch. So what happens is when I close the switch over here, the current, at this point the battery is producing current. It gets to this junction and it has a choice. It can go through the light bulb or it can go through this other section, but this other section is opened with a switch, and so the current can't flow because it's not a complete circuit. But once I close the switch, essentially there's a fire over here. And so all of the current is going to want to go through that short where there's zero resistance. And if there's zero resistance, there's going to be a whole lot of current. So you can't even, I mean, it's crazy, right? This number is just a huge number. This, I can't even read it, right? It's like 146,000 amps. The middle one is still getting some current. If this was a perfect world, that light bulb actually would just go out. But there must be a little bit of resistance in the wires or something like that. So in general, you can have a short which can cause a fire in that battery because it's trying to draw too much current.